All right. Hey guys, we're just gonna start our live stream here. Couple more days left before your exam. Really hope that your math exam went well today, but I'm assuming that you guys are now finished. Maybe took a little break for this afternoon, and now you're ready to start studying properly for science. Since our science exam is this Tuesday, coming Tuesday at 9. Just to remind you, we do have a tutorial from 9 to noon on Monday, so the day before the exam. I will also do another live stream Sunday night and one on Monday night as well. Okay? So I just want you guys to make sure really quickly, I'll give you a second to see if you have this practice exam number 2 that we went over. We went over this one in class a little bit, but like I'm just not really sure if you guys had this ready to go because we kind of skipped forward afterwards because people wanted to focus a little bit more on the checklist. I need you guys to give me a quick second here because I can't really tell if you can see what's going on here because it looks like to me that there's a bit of a lag. Okay, well, I'm just going to go for it anyways. I think there's a little bit of a lag between what I'm writing and what I'm saying. I'm not sure why it's doing that, but I'm just going to keep going. All right, so for now it says, for question 13, we already went over part A of the exam, but part B is constructed response questions. So that means you kind of have to come up a little bit more with an actual answer. Oh, I just have Brooke's question really quick here. Hi, Miss, could you go over the reproduction part of the checklist after the practice exam? Yeah, for sure. And thanks for putting that out there. I do want you guys, at the same time, if you have questions from the checklist, type that stuff in because I think it's good for us to go over the checklist as well. So if you have questions from the checklist or parts you don't understand, go ahead and type that in while we're doing this and I'll answer them after. All right, so first of all, if we're looking here, Mecca has just recovered from the measles, a viral infection. He would like you to explain to him how his body fought off the infection. So the first one says, which cell type is responsible for the defense of your body? Okay, so right away, we're looking at lymphatic system here. So it should tell you right away that we're looking at one of the types of blood cells. But as you guys know, the ones that are responsible for protecting our body are the white blood cells. Okay, so I'll write that in here. All right, then it says, what is one method that this type of cell uses to fight off infections? Okay, so the different kinds of things that you could do to fight off infections are creating antibodies. So you only have to write one of them, but the antibodies are those little Y things that we saw in the Magic School Bus that they were setting up and like kind of throwing at the bus and at the virus to try and fight it off. So it's something that your body creates in order to react to a virus. And that way, if you catch the same virus again, your body has now learned to fight it off and you would be immune. Okay, so there's antibodies, and the other way is called phagocytosis, which is when they change their shape and swallow the virus. Okay, so they would be able to they fight off the thing that's the bad guy is called the antigen, and they would be able to swallow that whole. Okay, the last one, why is McKay unlikely to suffer from measles in the future? Okay, so that's what I was just saying. If you catch the same virus again, once you're immune, okay, we can say he is immune, which is like immunization, because you cannot suffer from the same virus twice. Okay, so that would be the case for that's what we do with the measles, that's what we do with the chicken pox. That's why we, when kids have the chicken pox, a lot of the times people will invite other kids over to try and catch the chicken pox too, because it's better for you to catch a chicken pox and deal with it when you're younger. It can be a lot more dangerous if you catch it when you're older. Okay, so that's just one example, but anything that we have vaccines for, um, if you're immunized, the two ways of immunization, that was a question on another exam, was antibodies that you create yourself, and the other one is vaccination. Okay, I'm just going to keep going through these exam questions, but keep typing your checklist questions, and as soon as we finish part B, I'll go into that. All right, so question 14 says, the ear performs two main functions, maintaining the balance in the body and converting sound into a nerve impulse. I don't think that this is going to be on your exam because it wasn't really mentioned on the checklist, so I'll just do it really quickly. But it says, below is a diagram of the ear with an internal view of one of the structures. Name the part of the ear that converts sound into a nerve impulse. So I'll go ahead and answer that right away. So what you would put, where in this part here that's actually changing it into a nerve impulse would be the cochlea. Okay, and then part B, explain the sequence of events that takes place from the time the sound enters the ear to when the nerve impulse forms in the auditory nerve. So what I would write here is like the series of how it enters through the pinna. You should write it out. If it's on an exam, I want you to write it out properly, but since we're doing a video, I'm just gonna write out the steps quickly. It goes into your pinna, which is the main part of like the outside of your ear that you can see. Then the canal. Then it has to go through your eardrum. So your eardrum vibrates and mimics the sound waves that are coming in, which in turn stimulates your ossicles to start vibrating. So those three little bones that we talked about. Then after that, it's transferred to the cochlea, which is where it transmits into an impulse, like we just said. And from the cochlea, it goes through the auditory nerve to the brain. Okay, so I'll just leave that. We'll move on to the next one right away because I don't think this is going to be on our exam, but this is definitely the type of question we're going to have. If anything, I think our question would be more likely to be about the eye and to be asking us about lenses, since both of those things were mentioned in the checklist. All right, so this one, Mayumi and her basketball team went out for supper at a buffet restaurant after their game. Their coach told them to choose foods that will help build and repair muscle tissue, as they had just played a strenuous game. The coach suffers from hypoglycemia, low blood sugar. She needs to consume foods that supply energy quickly. The available foods are listed in the table below. And now we're going to be looking for two things. We're going to be looking for how to deal with the fact that they need to help build and repair muscle tissue. And we're also going to be dealing with this hypoglycemia here, so low blood sugar. So the first part says, suggest two foods that Mayumi and her teammates should choose if they want to build and repair muscle tissue. So for this one, since we're looking at muscle tissue, we should be looking for protein. Okay, so you're going to choose foods that have protein. So that would be mostly the meats that are in here. So you could have put lamb, you could put chicken, you could put, let me check out what else there is here. You could put chickpeas because that is a legume, which we said was a supplement for meats. It also has protein in it other than meat. And you could also have put bananas. And the reason for being able to put bananas is that bananas help relieve cramps or muscle pain in your muscles. Okay, so it's important to realize that you could have put bananas, but it's not because bananas are high in protein. They're high in potassium, but that does help with muscle cramps. So that's an acceptable answer. For B, it says suggest two foods that the coach could consume to supply energy quickly. So they right now have low blood sugar. We want to supply energy quickly. That means we're going to be looking for carbs. But the ones that provide energy quickly would be like simple carbs. Okay, you can write in the answer key, it said that we could get away with anything that had carbs in it, but what you would write mainly would be for quick carbs would be the coleslaw. You could have broccoli, or you could put brownies for the quick ones because those are high in sugars. But then the more complex carbohydrates would be like if you put pasta, rice, or bread, those things too, even though they're complex carbs, those are supposed to give you energy in the long term. But on my answer key that I had, it said it was acceptable as long as you were anything that was carbs. Okay, so I'm just going to go to question 16. Okay, so question 16 says, many people from around the world have signed up to take part in a new reality TV show about traveling to Mars and setting up a human colony. As living conditions on Mars are very different from Earth, you were told that once you arrive on the red planet, you will need to create conditions that are conducive to the maintenance of human life. And then it just wants you to name 3 conditions that are conducive to the maintenance of human life. Okay, well, this right here is Earth and space. So you don't have to do it. But I think that if this question did come up, I'm pretty sure you would be able to answer that. So you would need to be able to write water, oxygen, food. And the other one that you could put for this would be appropriate temperature for you to be able to survive. Okay, so you don't have to know this because this is Earth and space, and like we said, we're taking that out of the exam for this year. But I think that this one would have been common sense, so you could have actually managed to answer this. All right, so 17. Sorry that my camera is lagging so much. I don't really understand what's happening. All right. Sarah purchased a sports drink that has a concentration of 31 grams of fruit concentrate, per liter. So 31 grams per liter. They're telling us the concentration right here. Okay? The following weekend, she made 3 sports drinks of different concentrations for her soccer tournament. The concentrations of the drinks she made are listed in the table below. Okay, so we have all of these concentrations, and they want us to answer which of the sports drinks listed in the table above has a concentration that was the closest to her purchased sports drink. So which one is the closest to 31 grams per liter? All right, so what we need to be able to do here is you need to be able to calculate each of these concentrations. And they have the concentration written there. It's just a matter of the fact that these units don't actually match up. Okay, so you need to be able to realize that if this is talking about grams per milliliter, we need to convert this. So what I'm going to do is if it's 0.05 grams in 1 milliliter, okay, you're going to put it equal to X over 1,000 milliliters. And the reason for that is that 1 liter is 1,000 milliliters. Okay, so we're going to try and figure out in 1,000 milliliters how many grams there would be. Okay, so then you just cross multiply and divide. So I'm going to do 0.05 times 1,000. Okay, so your answer for this should be 50 grams. So the first one, oh, I just realized you can't see what I'm doing. Okay, the first one comes out to 50 grams per liter. All right, the second one, when you have 15% mass over volume, that means you have, when you see this 15%, that always means that the top part is 15 grams. But when it's talking about percent, that always means per 100 milliliters. Okay, and same thing, we're still trying to figure out how many there is in 1 liter. So we're going to put equals X over 1,000 milliliters. So again, you're going to do 15 times 1,000 and then divide by 100. Okay, so that should give you 150 grams per liter. Okay, and then the last one, we have 2.8 grams over 100 milliliters. And again, we're putting it equals X over 1,000 milliliters. So for the last time here, we're just going to cross multiply 2.8 times 1,000. Okay, divided by 100, which is 28 grams. Okay, and if we look back at the question is which of the sports drinks listed is in the table above has a concentration that was the closest to the purchased one. So the purchased one was 31 grams per liter. We have 50 grams per liter. Here, I'll put them over a liter here. 150 grams per liter or 28 grams per liter. So your answer here should be pretty clear that out of those options, 28 is the closest to 31. So your answer would be drink C with 28 grams per liter. Okay? If you guys have questions about any of this stuff while I'm going through, feel free to type in, but also if you're watching this at home later, you can send me an email or whatever and just say which question it was. So this was question 17. If you're not sure about this, I can go over this with you again, so just let me know. Okay? Question 18. All right, so question 18 says, Seamus is doing a laboratory exam and has been asked to identify a liquid and a solid by finding their densities. Okay, so this was something that was mentioned in your checklist. It was saying being able to identify a liquid and a solid, like an unknown liquid or solid. So this is where this comes in. It's like they've given you something and either you have a multiple choice question like this where you have to match it up with the unknown, or you're going to have to calculate something. So here it even told us that we have to use it by finding their densities. So he performs the following procedure and records his observations in the table below. All right, so he measures the mass of an empty cylinder. Then he adds 40 milliliters of the unknown solid. Finally, he measures the mass of the cylinder with the liquid. Okay, so we have to first of all realize that when it says density here, density equals mass over volume. Okay, so that formula, if you don't remember it, just keep in mind that you have an appendix at the back of your exam, and that formula will be in the appendix, okay? But it's just mass over volume, all right? But the thing is, we have to take into consideration here that this, like the mass that they gave us here of 82.9 grams, so it says mass of cylinder with 40 milliliters of liquid, okay? That is not the actual, like that's not the mass of the liquid because it's including the cylinder. So it gave us the mass of the empty cylinder. So what you need to do is you need to do 82.9 minus 32.5 grams to figure out how much it is, like how much the liquid is actually, what the mass of the liquid is. Okay, so if you do that, you should have got 50.4 grams. Okay, we're supposed to write our answer in grams per liter. So if we have 40 milliliters, I'm just going to go ahead and change this into liters. Okay, so if we move that over, 40 milliliters is actually 0.04 liters. So what I'm going to do is I'm going to do density equals mass over volume. So we're going to do the mass divided by the volume. So it's 50.4 divided by 0.04. Okay, so you should end up with 1260 grams per liter. Okay, so that was the first one because if you see at the bottom it says calculate the density of the liquid. So this would be one of your answers, would be 1260 grams per liter. The second one is a little bit more difficult because you're going to have to actually calculate area here. So it says he measures the mass and dimensions of the object. So it shows you the object. It's supposed to be on the middle here, but I don't know why I printed it out on the side. So we have the mass, okay, and we also have these dimensions. So to calculate the density for this, we actually, because one of the forms we had of measuring density was in grams per centimeter cube. Okay, so we can write it like that. So we're still going to have to use this volume, okay, mass over volume. Well, volume of this, you do length times width times height. Okay, and you guys should know how to do this for math. So you're gonna multiply all three of these things. So you're gonna do volume is 2.5 times 1 times 2, which should give you 5 centimeters cubed. Okay, and then afterwards we do the same thing again. So you do density equals mass over volume. So this time your mass is this, 13.5 grams. And you're going to divide it by 5 centimeters cubed. Okay, so it should give you, that should give you density equals 2.7 grams per centimeter cube. I realize you can hardly see what I'm doing here. Okay, so your answers here, this one should have been 1260 grams per liter, and the second one should have been 2.7 grams per centimeter cube, like this. Okay, if anybody has any questions about that, because I know we didn't do a lot of this volume stuff in class in this format, so if you're not sure about that, feel free to type in about that. I do see that Callista, you got a couple questions to do with helical rotation, different kinds of movement and stuff like that, and I see Brooke's question from the checklist about the reproduction. So we're going to move into that really soon. I just want to make sure we get through part B of the practice exam at least. Okay. So question 9. It says a laboratory technician would like to dilute a 3.0% mass over volume solution of sodium chloride, NaCl. She takes 250 milliliters of concentrated sodium chloride and adds water to prepare a 1.5 liter of the diluted solution. So what is the concentration of the new solution in percent mass over volume? Okay, so what we're going to do is we're going to use our formula for dilution. So again, that's going to be in your formulas that you're going to have on the exam. So the formula for dilution is concentration 1 times volume 1 equals concentration 2 times volume 2. Okay, and what we said was that the two concentrations have to be in the same unit and the two volumes have to be in the same unit. Other than that, it doesn't really matter. So the fact that this is in a percent, please don't let that freak you out, because it does not have to be, it doesn't have to be like, you don't have to put it into grams per liter, okay? So you can just use this 3%. So this is going to be our C1 is going to be the 3%, okay? We start out with 250 milliliters, so this is going to be our V1. The only thing is here that if we have 250 milliliters, we also have our V2 here, but the unit is different. So instead of writing 1.5 liters, I'm going to write 1,500 milliliters, okay? Because if one of them is in milliliters, we have to put the other one in milliliters too, okay? And here we have 3%, and then that's fine because they want their answer in percent mass over volume, okay? So if this one was in percent, that unit matches up here, so we can write it like that too. Okay, so we're just going to plug this in. So C1 is 3, so I'll write it again down here. C1 times V1 equals C2 times V2. And then it's just like you're solving for a variable in math. So C1 is 3 times V1 is 250 equals C2 is what we don't know, so that's our unknown part. Okay, and then times 1,500 milliliters. Okay, so in order to do this as a math equation, if we want to get C2 by itself and it's multiplied over here, we're just going to do the opposite. So you're just going to divide on this side by the 1,500, divide by 1,500. So then you get C2 equals, and you just plug this into your calculator. So you do 3 times 250 equals, equals 750 divided by 1,500, and it gives you 0.5. Okay, so that means that's your answer. So you're just going to write that the answer is 0.5% m over v. Okay, so you just write it like that, and that's it. Okay, do I think there will be a question like number 18 on the exam? Okay, let me look at that. So question 18, I do think there will be a question like this. I do not think that it will necessarily have like a solid object to do as a volume like this, okay? So I don't think you're gonna have to do any kind of like volume, mathematical volume to be able, because we haven't like, that's a math concept, but there is definitely an overlap between math and science. So like they definitely are not going to ask you to do the volume of a sphere or a cylinder or anything like that, because that's not like a basic kind of volume. All right, so we will have to be able to do maybe something like this, but I haven't seen it on any of the other practice exams. I can't tell you for sure because even right now, like I've asked when I'm allowed to look at the exam, and I'm only allowed to look at it 15 minutes before you guys see it. So I haven't seen the exam, so I can't tell you for sure, Gabby, okay? All right, sorry about that. Okay, so we'll go back. How many more questions do we have in this section? We have 2 more questions, and one of them we don't have to do, so it's just really one more. Okay, so it says, Rosa is working part-time as a pool cleaner. She observes the following 2 phenomena while cleaning the pool. Number 1, she can see an image of a tree on the surface of the water. Number 2, she notices that the pole appears to be bent once it has entered the water. Okay, and then the question just says, what is the name of each phenomena as she has observed, and explain each phenomena. So you have to be able to explain what it is. All right, so if you just look at these, this is the chapter that we just finished doing very recently, so this should be pretty familiar to you guys. But the fact that she can see an image of a tree on the surface of the water, this one for sure is reflection. Okay, so one of the things that we know that happens with light waves is reflection. So you would just have to be able to say, explain what that means. So I would just write the sun rays bounce from the tree to the water and then your eye. Okay, something about how the light rays are bouncing off the water, anything like that would be clear enough for you to be able to answer this. Okay, Callista is saying, is the live stream working because I can't see or hear anything? Can somebody else at least write for me to make sure that you guys can hear me still? Okay, well, I'm going to keep answering, but as far as I can see, I don't really know if it's working or not. I really hope it's still working. Gabby just said, okay, thanks from before, so I guess she could hear me while I was answering that question. Okay, people are saying it's still working, so hopefully Callista figures it out. I'm going to keep going. All right, so number 2 here says, so she notices that the pole appears to be bent once it has entered the water. So as soon as it's talking about light rays being bent, this one we should know is refraction. Okay, and the explanation for refraction, I'll just write it underneath. Obviously, you guys would have an answer booklet to write this in, and it wouldn't be as sloppy as the way I'm writing it onto here. Okay, but refraction, so the way that this pole is bent where it's making contact with the water here is because you can say light rays bend because they change speed as they change from one transparent medium to another. Or you could just say from the air to the water. One transparent medium to another. Okay, so when we're talking about a medium that's a solid, liquid, or gas, just remember that light rays are able to travel even without a medium. But the other ones, because those are electromagnetic, but the other ones, so mainly the mechanical ones, and the one we use as an example for that is always a sound wave. Sound waves cannot travel in space, and the reason for that is that they need a medium to travel. So I'll just write underneath, a medium is a solid, liquid, or gas, but they always write it just as medium. Okay, so because it's moving from the light is moving from the air to the liquid right there, it just changes speed right as it's hitting that, and it kind of like as it's reflecting into your eye, it's refracted, so it looks like the pole is bent. Okay, so you just have to be able to explain what that means. So that is the kind of question I think we're going to have on waves, and the other practice exam that I have for you guys for us to do on Monday at our tutorial has a question about sound waves. Okay, so I think it's going to be either something like this or one of the ones with the lens, like when it's asking you if someone has myopia, what we're supposed to do, what kind of like corrective lenses we would give them. So I think it would be that, or something to do with sound levels and like energy levels in a wave. Okay. The last question that was here, this was about, okay, this question 21 in here was about solubility, but it was saying the solubility graph below illustrates the effect of temperature on the solubility of a variety of substances, okay? And then it was asking you which substance shows the least change in solubility between 0 degrees and 100 degrees. We did not study this year, so like we didn't have to do, Mr. O'Brien's class didn't do it either. We are not doing anything this year that has to do with variation of solubility or variation within temperature. It is, however, important for you to know what solubility means. So I'm going to cross out the question, but I want you to make sure that you know that this is one of our characteristic properties. So that means if two things have the same solubility, you can decide that it's the same thing. But solubility is like, I don't really know how to explain. It's how much you can mix in there. Before it will stop mixing. So our examples that we used of this in class were with Kool-Aid or with hot chocolate. When you're making yourself a Kool-Aid or a hot chocolate, when you're putting the powder in there and putting the liquid and mixing it, eventually, even though you might want your hot chocolate to be like really, really chocolatey, if you just dump half the can of powder in there, it's not actually going to mix into the water. It's going to clump up at the bottom. Okay, so the solubility is the maximum amount that will actually mix into the water before it starts to just clump and fall to the bottom. Okay, so you need to know what it means. Okay, Kayla is asking, is that like the solvent and solute? So yeah, you need to know it's kind of solubility is the max solute that can go into solvent properly. Okay, you do need to know that solute and solvent, this is the part you're mixing in. This is the thing that's mixing. So like this would be your Kool-Aid mix, and the solvent would be water. Okay, so you do need to know solvent and solute. All right. Okay, so I'm just going to stop with that. Well, I'm going to let you guys decide right now, the people who are actually watching. So there's always a little bit of a delay here, but would you like me to move on to part C, or would you like me to go over the questions in the checklist? So much of a lag going on here. If nobody answers, I'm going to do part C. Okay, Kayla's saying part C. All right, let's just do part C, you guys. Ooh, no, Gabby's saying questions from checklist. Now I have to do both. I guess I'll do both. I just don't want this video to be like an hour long for people to have to watch at home. All right. I don't think even question 25 from part C we don't have to do, so it's actually only going to be a couple questions. So I'll try and do them quickly. Okay, so it says doctors are setting up clinics in various villages in Africa. They require the use of a centrifuge to help test blood and diagnose patients. The villages have limited resources, so it's practical to have a portable hand crank centrifuge. A model of centrifuge is illustrated in the diagram below. So they've given you, during part C, it's tech analysis. So they give you some kind of object. In this case, they've given us this centrifuge. And what we're going to have to do is all of the questions after this are going to have to do with the centrifuge and about how the different parts and components work. Okay, so I'm just going to go, everyone wants me to do the checklist? I have to at least do this question, you guys. I started already. Okay, so we're just going to go see what's going on and what it's asking us. So the first one, question 22, is talking about the hand crank of the centrifuge, and it's asking us what is the function of the cylinder in the diagram above, and it actually gives us these options. So this is important for you guys to know. Out of these options here, it's saying guiding, linking, lubricating, or sealing. So we have to be able to explain which one it is. Okay, so if it's talking about the cylinder, it actually pointed right in here. It's talking about this cylinder. Okay, so it's asking us what it's for. So the answer for this was guiding, and it's doing a rotational motion. Okay, so rotational motion, and I noticed that that's actually one of the questions that somebody had from the checklist, is what rotational motion is. So rotational motion is something that's spinning, like turning like this. We also have, so like something you're rotating, so this would be circle. We also have linear motion, which is something that moves either from side to side or up and down, okay? Or that can also be called translational. So this is rotation, linear, translation, and then the third one that we talked about is called helical, and this is the one that's a spiral. Okay, so that's when you have like a screw that's spinning or something like that. Okay, so it's guiding, it's rotational motion, but if you're going to explain your answer, you would have to say that when you turn the handle, like the cylinder is guiding the direction of like what's turning inside. Okay, so just explain that in however way you want to. The second one said, what is the function of the bracket and screw in the diagram above? So it's talking about this part here, and I find this picture to be a little bit unclear. Okay, but this part down here is supposed to be attaching it to the table, so that would be linking. So attaching to table. All right, Brooke is saying, when did we get that package? So that I didn't even switch packages. I'm still doing the exact same one that I was. It's just that I gave you part B and C in one section. So I gave this to you like a week and a half ago, maybe. I feel like everyone should have this. You can get a copy from me on Monday if you would like one, but it's exactly these questions that I'm going over right now. Okay? So I'll just move on. I'll do these really quick. It's not going to take that long. So I know in your math exam, part C always seems like the most massive and overwhelming part. In science, it's part B that you have to do the most writing. And then part C, you're just analyzing some kind of tech object. So it shouldn't be that tricky. It's just like figuring out what's going on with whatever object they've given you. Okay? So for this one, they're showing us the inside of the centrifuge. And it says, name the type of motion system that is illustrated. Okay, so when they're saying that, so they're talking about component 1 and 2. Okay, so component 1 is a gear, and component 2 is a gear. So that's actually what they're asking you, is just to write, like, what kind of system is this? So you just, all you have to write is gears. That's it. Okay, and just remember that if you have wheels that don't have teeth on them, those are called friction wheels, but if there's teeth on it, it's called gears. Okay, that's all you have to write for A. And then it says, is the motion system a motion transmission or a motion transformation system? Okay, so if we're looking at component 1 and component 2, component 1 is a rotational movement, right? It's a circle and it's turning, so that means it's rotational. Component 2 is also a gear. It's also turning, so it's rotational. If it's going from one component to another and it's keeping the same type of motion, then that's transmission. Okay, so the answer for this is transmission. If it was changing to a different kind, so if you started out with rotation and then afterwards it was going up and down, okay, if it was switching to a translational motion or a helical motion, that would be a transformation. So we said like transformers, you're changing what you're doing. In this one, rotation, so that's transmission, you're keeping the same thing. Last part, identify the driver component and the driven component in the system. So it's asking you, we always said the part that's doing the driving, okay, the driver is the part that you're actually moving, okay? And when we talked about a bike, we said like you're putting your foot on the pedal, so the pedal would be the driver component, and then your tires are spinning, so that would be the driven component. It's being driven by pushing your feet, okay? So driver component in this case would be the handle. So handle is the driver. Your explanation can just be like, you are putting force on this. So your hand is putting force on the handle. Okay? And then the handle is transferring over to the gears. Okay? So because you're turning the handle, this cylinder in here is turning, and that's what's turning the gears. Okay? So the part, especially you could go, it's going from gear component 2 to component 1. So the gears are the driven. Okay? I am going to answer all the questions you guys are writing for the checklist. I'm just going to finish this because we don't have to do part 25. Question 25. I'll explain that in a second. But this will be the last question and then we'll go into the checklist. Okay, so question 24. The centrifuge will be used to test blood samples of many patients. It will be washed several times a day and be exposed to open air and extreme temperatures. It will also be transported on rough roads to various villages. Okay, this is where we're looking at properties of materials and you have to actually write an answer. Okay, so it says, the table below provides some properties of various metals. Sorry, it's showing you a picture again, but it's basically what they talked about above that you have to focus on. So properties are listed here, and you're going to have to say which of the materials listed above would be the best material to use for the centrifuge. Okay, and you have to explain your answer providing 2 reasons for your choice. So you have to look at the properties that are listed here. All right, it said at the top, the conditions that it's facing is, first of all, it will be washed several times a day. And we had this in the previous practice exam as well. If it's being washed several times a day and it's going to be exposed to open air and extreme temperature, it says it will also be transported on rough roads to various villages. All right, so if it's going to be washed several times a day, you're looking for something that is corrosion resistant, because if it's not, that means it's going to get worn down by washing it. Okay, so you need something that's corrosion resistant. And then it says exposed to open air and extreme temperatures. So like if it's going to be in extreme temperatures, you might want something that is well, you wouldn't want something that's a good thermal conductor, so I would say cast iron is not a good choice. You would probably want something, I would say for this, just don't choose thermal conductor, because that means if you're going to be in really hot or really cold weather. If it's a thermal conductor, then that means it's going to get really, really hot or really, really cold. All right, for this question, Kayla is asking, on the exam, will there only be one tech object to analyze? Yes, it's going to be the same thing. So on the previous practice exam that we did, there was a microscope. On this one, they've given us a centrifuge. On our exam as well, they'll give you an object at the beginning, and you're going to have to analyze a bunch of questions about that particular object, okay, like we're doing right now. All right, so back to this really quickly. It also says it will also be transported on rough roads to various villages. So what I would choose here, I would go down here and I think I would probably choose aluminum. Okay, but what I'm trying to tell you is there's not necessarily a wrong answer here. You have to explain why using these things. And it says to give 2 reasons. So I would say aluminum, and my 2 reasons would be it's resistant to corrosion, and I would explain so it won't get damaged with washing. Okay, but my second reason, because we could have had that for stainless steel as well, but my second reason for me would be that it's going to be transported on rough roads to various villages. I would say it's light. Okay, because in here the density is kind of like how heavy something is. So in this case, this one has the lowest density. To me, that seems like I would explain that it would be easier for people to transport it because it's light, and I would say that it's more resistant to corrosion. So those would be my 2 reasons for that choice. But as long as you explain why you chose that answer, like there could be answers that are definitely wrong, but for the most part, if you can explain your answer, this is like an arguing kind of thing. Okay? All right, so and like I said, question 25 in this exam that we had, this question that was asking us about cell culture method afterwards, it was talking about centrifuges and cell culture. This is the biotech chapter that I said is not in our program anymore. Calissa's asking, is stainless steel still okay? Yeah, so if you chose, for question 24, if you chose stainless steel instead of aluminum, and you said, if you said same thing, it's resistant to corrosion, and it's hard, so it probably won't break while they're transporting it, that would be fine. Like as long as you give 2 reasons that are supporting why you think that that would be a good choice. Okay? So stainless steel would have been an acceptable answer as well, just as long as you argue your point. Okay, so like I said, we do not have to do number 25 because this was a biotechnology question, so please don't freak out if you did not know how to do question 25. All right, so that's pretty much that. We had already done a previous video going over part A of this exam, so I'll stop this, but I will answer checklist questions. So feel free, I'm going to scroll up in the list here. Okay, so you guys have your checklist. I feel like we're mostly okay for Living World. I could do a live stream where I actually go through the whole checklist at some point if you guys would like. I could do that over the weekend. I'm just going to scroll up to what people were saying in the questions. So very early on, I had a question from Brooke to go over the reproductive part of the checklist. Okay, so if you go to the second page at the bottom for reproduction, is it just for the reproduction, we kind of have cell division and then this reproduction part. So you do need to know mitosis and meiosis. So I can describe the functions of mitosis. So mitosis is for reproduction, growth, and regeneration. So by reproduction, that means like reproducing the same kind of cells. Then I can describe the function of meiosis, so production of gametes. So these ones have 46 chromosomes when they make the new cells. These ones, production of gametes, these are your sex cells. So you need to know that word. So there's your sperm or ovum. All right, and these ones, you can't even see anything I'm writing. Okay, so these ones, sperm and ovum, and they have 23 chromosomes. It's because you're making half the amount of chromosomes, because ideally what's supposed to happen is that it matches up with someone else's to create another human, and that's the point of your sex cells. So that's why you're making half a set of chromosomes. Okay? I can distinguish between mitosis and meiosis based on their functions. So that means if it's saying that, then that probably means you're going to get that multiple choice question that's saying which one of these things is not a function of mitosis, and it'll say reproduction, growth, regeneration, and production of gametes. And you would have to say production of gametes because that one's meiosis. Okay, so hopefully you guys are okay for cell division, but if you're not, you can ask me to go over it on Monday. I've gone over it in a couple of the tutorials now, okay? But if you need more help with that, no problem, just let me know. For reproduction, the only thing it says I can name the hormones responsible for the formation of spermatozoa. So there's follicle stimulating hormone, which is FSH, luteinizing hormone, which is LH, and testosterone. Okay, so all of the sex hormones that we talked about, FSH and LH, these come from your pituitary gland, which is in your brain. And what they do, this we have both male and female. Okay, males and females both have FSH and LH. This stimulates puberty and sex cells. Okay, males and females both have this. But then we have testosterone, which is male. Okay, that doesn't mean that females don't have any testosterone at all, or that it's impossible to have testosterone. It just means that is the predominantly male hormone. Okay, so this one would be male sex hormone. So this is for producing sperm. It has secondary characteristics as well. So like just like generally the fact that guys would start to at some point start to have facial hair, pubic hair, all those things are also coming out of testosterone. The female ones are estrogen and progesterone. Okay, and these would stimulate ovulation and menstruation. Okay, but it says that they're gonna, it's telling us to focus on male. It doesn't say anything about female. So I guess the question is going to be about male sex hormones. Okay, so I'm just gonna scroll back down here and see if there was any follow-up to that. All right, so hopefully that's okay as an explanation for the sex hormones, because there hasn't been any follow-up question. You can type now if you have a question about that. I'm still gonna go scroll up a little bit here and see what else there is. Gabby's asking, what is the difference between pulmonary and systemic circulation? All right, so let me just see in one of these practice exams if I have a picture for you. 1 second. So pulmonary circulation, pulmonary is always talking about your lungs. So you have the right side of your heart pumps blood from your heart to go to your lungs. And the reason it has to go to your lungs is because it has to go there and get rid of carbon dioxide and pick up oxygen. Otherwise, you would just be circulating more carbon dioxide back into your body. Okay, so I found one of the pictures, so I'll just put this. Okay, so when we look at this, so from the right side of your heart, so when it comes into the right side of your heart, it's coming from your system. It's coming from systemic. It goes into here. All right. It right now would be blue because it would have carbon dioxide. Then when your heart pumps, it would go out through here. Wait a minute. This is not even the right thing. Oh yeah. Okay. It would go out through here and go to your lungs. So one would go this way to this lung. One would go that way to that lung. Then, so when it's going in there, that's pulmonary circulation because it's circulating to your lungs. So it would go in there and get clean oxygen, come back with blood full of oxygen, and come now into the left side of the heart. Then when it's in the left side of the heart, now it's going to pump to your whole body. So when it goes to the whole body, that would be systemic. Okay, so pulmonary is to go to your lungs, systemic is to go everywhere else in your body. Okay? Let me see what else we got here. All right, there was questions about solute and solvent. I think I answered that stuff. What is rectilinear movement? Water bottle cap, helical, or rotational movement? Okay, so the different, I think I covered that in the question that we were talking about. So the different kinds of movement that we have seen was rotational. I'll write rectilinear, but when we're speaking casually, we would just say linear, but they also could call this translational. Okay, and we also talked about helical. So this would be a circle. This would be a line. And helical is a spiral. Okay, but when Callista was asking about a water bottle, when we twist a water bottle cap, because it's actually twisting and it's moving forward, like either it moves upwards or downwards, that would be a helical. So this would be water bottle cap. Okay, and then circle would be like when you have gears that are just turning perfectly in a circle and they go back to exactly the same space. This would be like a gear. All right, and then this would be sliding door. Okay, because it's if you have like your back door, like a glass door to go outside that you would slide back and forth, that would be a linear motion. Okay, I think that hopefully that's a little bit more clear. So if, like we said, when we have transmission or transformation, if you start out with a circular motion and you stay in a circular motion, that's transmission. If you start out in rotational and then the second component is doing something else, so it's doing linear or helical, then that's a transformation, so it's a little bit different. Okay, let me just see if there was any other questions here. Okay. I don't think anybody else had any other questions, so I'm going to cut it off here. Sorry, this was much longer than I thought it was going to be, and we'll do another live stream on Sunday night. So I'll text you guys the time again for the live stream Sunday night. Actual tutorial in person on Monday, and I have another practice exam for you guys. But we can also go over any of the notes that you want to, any of the checklists, practice exams, whatever you want to do on Monday, that's what we'll do. And we'll do a live stream Monday night too. All right? Have a good weekend, guys. Good luck.